Sketching the graph of sine function. Until now, we have drawn sine functions using a table of values and then plotting. We shall now use the characteristics of a sine function to draw a sketch graph. A sketch graph is a rough sketch of a function that gives its shape, the domain and range, the intercepts on the axes if they exist, and the amplitude. Let us sketch the graph of the sine function y equals f of theta equals 1,5 sine theta plus 2 for 0 degrees less than or equal to theta less than or equal to 360 degrees. First, examine the characteristics of the given equation by comparing it with the standard form of sine function y equals a sine theta plus q. Here, a equals 1,5 and q equals 2. From this, we can see that a is positive and greater than 1, which means that the graph is sketched vertically, and q is greater than 0, which means that the graph is shifted vertically upwards by 2 units. But we don't know yet exactly where the function will intercept the y-axis, nor its amplitude. Let us find those before we can sketch the graph. The y-intercept is found by setting x equals 0 in the function. Y equals 1,5 sine 0 degrees plus 2 equals 0 plus 2 equals 2. Y-intercept is 0 degrees, 2. We also mark this point on our sketch. Amplitude. We saw earlier that the parameter a determines the amplitude of the sine function, while the line about which the amplitude is measured is given by the parameter q. Here, the amplitude is measured from the line y equals q, therefore y equals 2. Since a is positive, the amplitude is a, that is 1,5. A is greater than 0, so amplitude equals 1,5. The maximum and minimum of the function are a plus q and negative a plus q, therefore 3,5 and 0,5. Turning points. The turning point of the sine function are at theta equals 90 degrees and theta equals 270 degrees. These are the maximum and minimum points of the function between 0 degrees and 360 degrees. We note that since a is greater than 0, the maximum turning point is at theta equals 90 degrees, while the minimum turning point is at theta equals 270 degrees. Now, we draw the sine function, starting from the y-intercept with the wave about the line y equals 2, reaching the amplitude on either side of this line and having its maximum at theta equals 90 degrees and minimum at theta equals 270 degrees. We can also mention the domain and range on the sketch. The y-intercept is 0, 2. We also note that the function does not have any x-intercepts. The maximum turning point is 90 degrees, 3,5, and the minimum turning point is 270 degrees, 1,5. The period of the sine function is 360 degrees.
Need more help? Subscribe to our channel. Can't wait that long? Ask Masky to help you and let the math finally start mathing.